Hi viewer, this is EasyElimu channel. I'm Vincent Kanmwai. I'll be taking you today through Form 4 mathematical work, and today we shall be handling approximation and errors. Stay tuned as I welcome you all. We're going to learn how to computing different kind of sums or mathematical sums using a calculator. That gives us a subtopic, computing using calculators, or how to use a calculator. And we know from our basic knowledge from where we are from, we know we have different kinds of calculators. We have simple calculators which are used by shopkeepers to do their numerical business sums, and we have some which are used for complex mathematical terms or analysis such as scientific. They are actually known as scientific calculators such as like this. And this one, as you identify, is from Casio company and it's FX82MS. This is what I shall be using for today to guide you through how to use it. And for the first thing, we shall start with the 4 basic operations using calculators. And from the 4 basic using or operation of using calculators, we shall start with the addition, subtraction, multiplication, and division. That are the major 4 basic, and they have their different keys given on the calculators that are also found on the simple and also on the scientific calculators. For instance, we shall start with the addition. Given different kinds of sum, for example, having 25 plus 263, there you put there equal. So, having given this kind of a sum, the first thing or the first step here, after turning on the calculator, the first thing you press, we have the calculator contain of different kinds of sets of numbers. We have different kinds of keys. You will identify some of the keys run from 0 to 9. We have 0 up to 9. Others have this point. We have different kind of them. Others every key of the function of that one. Others have x. The others have divide, and then we have addition. We have subtraction. We have the equal sign key. They are of different kind. Each of the calculators have different kind of mode of displaying its own analytical mathematical concepts. But here, these are the basics of that given system you are using. For ours, we shall be using FX82MS, and from there we can see, from there we have 0 to 9, and then those given signs for mathematical analysis. And then from there we can start ours. We have the del key is for deleting. If you have put in a different kind of a number and you want to delete, you use the del key. But for this sum here, we say we shall start with the addition, and with the addition we shall key in, or you press number 2, the key of number 2, whereby we can identify it as 2 here. So you press in or you key in 2 key, then followed by that step 1. Step 2, you key in 5, and you will find that if you key in 2 and 5, you will find it displays them on the upper part, and that is 25. Then you key in addition key. You key in positive or addition key, which we say press positive or plus key here, and you shall see it will write 25 plus with any kind of calculator you are using. Then step 4 actually, you key in 2, and if you key in 2, you will find it continues to write that way, and the process continues. You key in 6, and step 6, you key in 3. You will find it writes that 6, 3, and then the final thing, you key in equal sign. That is step 7. you key in equal sign, or you press the equal sign, and you will find the screen displays 288. The screen displays 288. So meaning that if you take 25 plus 263, it is giving you 288. 288. That is the answer for that. So if you have been given any kind of numerical addition, mathematical concept, for example like this, it may include different kind of digits. What you shall only do, you only key in the given numbers to the calculator and direct it what you want it to do. If it's the addition sign, you put or you press that addition sign, and if the numbers you press, and then at the end, if you want to find whatever you ready to find, you press in equal sign, and the screen will display the answer you want on the screen, and you read it as we have seen. That's how we do with the addition. Now we have dealt with addition. Now let's see how we can deal with the subtraction. And we have seen for this instance we have started with negative 6 plus 15. Now from this point we see this is positive is the same. We have been given this one is equal to question mark, and from that point we can identify that on our calculator you will find two keys. We have one for subtraction down, and we have another one on top which is written in bracket. This is a negative sign, the same with the first denominator there. So what you do, you key in n of them. That's the first step. Key in the negative sign, either on the top here or the one at the downside part. And then step 2, you key in or you press in number 6. So number 6 is here. I've keyed number 6. Then you key in for step 3, you key in positive sign. And positive sign you will find it at middle, and it is for any kind of given sum within a negative. Or after keying in, then you key in for step 4, key in number 1. If you key in 1, you will find it displays on the screen. Then for the 5th step, key in number 5, and you will find it also displays, the information also displays on the screen. Then for step 6, key in equal sign. And if you key in this equal sign, you will find the answer displays on the screen. And you will find here the answer which displays, on screen. And you find that answer is equal to 9. The answer which displays on the screen is 9. So meaning if you take negative 6 plus 15 or 15 minus 6, you are going to get 9. So that means for any kind of subtraction or any given digits with the subtraction, you do the same procedure, just identify the given digits and then you press them on a calculator with the given signs, and you will give, the calculator will automatically give you the required answer. Now let's see another one. Let's deal with the multiplication. And this one still works as the same as addition and subtraction, but the only difference is the sign. For the multiplication, you will find that having been given 35, for example, multiplied by 42, you will find for the first step here, you have to key in 3. Keying in 3 means you press number 3. So if you press number 3 here, then the second one you follow, you key in number 5. That is the 5th digit. You key in the 5th digit, that is 5. Then for step 3, key in the multiplication sign here. The multiplication sign key is located at the center. If you have that, you will see. Then you key in 4 and key in or press 2, and the final one you press or key in equal sign. So you will find it displays on the screen, the calculator displays 1470, and this is the answer for here. Now we can say this one is equal to 1470 or 1470. This one we found was 9 and this one was 288. The same applies to the division or the quotient. You will find for division, let's take for example, we have been given an equation like 3.51 plus 4.51 over 7.5 multiplied by 1.28. Here it's like we have combined several of them and we need to calculate them using a calculator. And as you see, we have one with the multiplication, and here we have introduced the dot. Here dot is a decimal point. It's a dot differentiating between the real numbers and the decimal ones. So this is the decimal numbers, and we can see them present in the numerator and denominator. So here, the first thing here we have to do it on a calculator. So we shall first take, we key in, you key in 3, followed by key in the point or decimal point key, then you key in 5, followed by 1, and the procedure continues. For example, you will key in 3.51, and then after that one you key in positive sign, then key in 4.51, and you will, after keying that way, after finishing the upper one, you have keyed up to 4.51, then you should key in equal sign, so that the screen displays 8.02. After the screen displaying 8.02, you now introduce brackets because we need to introduce the denominator. So after that one, you say now divide by. So after the screen displays 8.02, you key in now the division key. You key in the division key. So if you key in the division key, you will find that it will display, the screen displays answer divided by, so that is what the screen displays. And if it displays that way, then you key in bracket sign with that way, the open bracket sign, and you will, after that one, you now key in 7.5. I believe you understand now how to key in that numbers. 7.5 multiplied by 1.28, and then after keying that one, you now key in a closing bracket that way. Now after keying that closing bracket, you now key in equal sign. After finishing everything, you have closed the bracket, and then you key in equal sign, and you will find the screen displays 0.8354166 recurring. So what we shall do here, you shall write 0.835 maybe 4 to 4 significant figure or 4 decimal places as you need it. So in that we have find how we can use it to calculate different numerical sums or multiplication or division or even subtraction using a calculator. Let's continue and see how we can find or how we can compute different kinds of mathematics using the same calculator. Now let's see how we can find square and square root of numbers using calculators. For instance, if you have been asked to find the square root of 289, the first thing you should do here, you key in the square root sign, and then after keying the square root sign, or some calculators may display the square root sign, or you find others have displayed something of the sort. You press that one, or others have displayed something like y square root of x. You key in that one first, and then after keying in that one, so you press your number, that is, you now key in what you have, that's step 2. Key in now 289. After keying your number, then for the third step now and the final one, you key in the equal sign, and you will find that for the 82FX82MS, you will find that the square root sign is present, and that way, so you just key in that square root sign, and then after keying in the square root sign, you press 289, and then on pressing 289, you press equal sign, and you will find it displays the answer as 17. So we can find that here the answer of square root of 289 we are going to find is 17. That one was for the square root, and let's handle the square. Now to find the square of any given number, you will find some calculators have some keys display as x squared for this instance, and others have xy and others have yx. It depends with the mode you are using. For 82FX82MS, you will find that it has this key display, and this one means that is the square key. So if you are being asked to find 19 squared, what you are only required to do here, the first thing, you key in 19, or you press 19, that is 1 and 9. After doing that, then you key in now this sign, the key there, which is x squared on top, and you will find on the screen it shall display something like that, that is 19 squared. So you key in, and you will find it display that one. So after doing that, the final thing you should do here is now keying in the equal sign. So if you key in the equal sign, you will find it displays on the screen 361. The screen displays 361, and that one means it is a square of 19. We have seen how you can find the square root of any given number using a calculator, and also the square of any given number using a calculator. You can press this one or this one depending on the mode of calculator you are using, but most of the schools, especially those for Kenya Institute Curriculum and Education, they implement that the calculator that should be used this FX82MS, so meaning that they will have the same or similar x squared on the calculator displayed. So that is what we shall be using, and that is we shall find the square by pressing that one after pressing the number, and also for the square root, we press the square root sign first, or the square root key. Then from there, we press the number to find that square root, and then from there, we press the equal sign, and you shall find the answer as we have seen. Cubes and cube roots of numbers using calculators. And we can see for these calculators, which are most used in secondary schools, we can see that on this here we have x cubed for the FX82MS, and we can see we have that key, and on top of that key we have something written like 3 3 like that, and then here we don't have something inside. So meaning that one is the cube root of any given number. So we can see those ones. So this one is identified as the key for finding cubes of given number. Key for finding cubes of given numbers. And this one here is key for finding cube roots of any given number. So for example, if you have been asked, find the cube of 4. Find the cube of 4, meaning 4 cube. What you should do here, you only key in 4. After keying 4, then you go up there on the black keys. Actually, they look like the calculator. It depends with the mode of calculator you are using. It might not be black, but the keys are almost the same. For the 82mx, you will find it has been written x cubed. So you press that and you will find key in x cubed, and you will find the screen displays 4 cubed. Then after that one, you now key in equal sign, and you find the screen displays to you 64. That means that 64 is the cube of 4. So if you take 4 cubed, you will find 64. So let's see how you may compute cube root. And we have said on top of x cubed, we are having this sign of cube root. Cube root, for example, you will find that we have on top of x cubed, it displays this sign of key. On top of this x cubed, you will find there is a small display of that way. That is how it is displayed. And if you want to compute any number, for example, given 216, find the cube root of 216. What you should do first, you key in shift key. So you'll go up there and then you key in shift key. After keying shift key, you now key in that x cubed key. And if you key in that one, you will find that the screen of the calculator displays this symbol. So that symbol represents the cube root sign. So after that one, you key in now the number you have been provided with. For this one, which we are handling, we have been provided 216. So that is what we are going to key in. And you will find the screen shall display cube root of 216. After doing that, you now key in equal sign. And if you key in equal sign, you will find the screen displays 6. So that means that the cube root of 216 is equal to 6. And that is how we can find cubes and cube roots of given numbers using calculators. We are going to see how we can find approximations and what does it involve with. For this instance, where we have rulers, we use rulers or tape measures, or we sometimes use micrometer screw gauge, sometimes we use vernier calipers. All those things we do use for measuring measurements of given objects. We will find that if we have been given the exact values which were used in measurement, and we compare them with what we find, we shall find there is a certain error existing from them. So meaning, whatever we have measured is just an approximation of the exact value of that figure or that given piece of land if it is for measuring a survey. And we shall find that in order to give that approximation, we do rounding off, or we truncate some of the digits so as to give some certain measurement. Now let's handle rounding off, and in this rounding off we will find that you will be given a certain place or a certain given number, and you require to round off to given significant figure or decimal places or any of them. So if given, for example, a number, let's say you have like 365.823. If you have been asking, let's exceed it a little. Let's be 8245. In case you want to round off any given number, the first thing you will identify is that you identify the number to be rounded off. If it is, for example, you have been asked, actually let me make it be a little bit different so that you won't be 7, so that we may not confuse. So if, for example, you want to round off the given number, which is now, for instance, like 6, we identify that this number, it is in a place value of, actually it is in a place value of 60, I think. The place value of it is 60. No, the place value is being 60. The place value of this number is tens. So if we want to round any given number in tens, you will look the number which is next adjacent to that number on the right hand side. For instance, if you want to round off this number 6, you will have to look at 5. This number 5 is the adjacent number to 6, and it is on the right hand side. Then the condition says that if that number, for example, if the number is x here, if that number is greater than or equal to 5, meaning that it should be within that range. Alright, let me give you the range. It is from 5 greater than or equal to 5, but less than 9, then that number can be rounded off to the next number. So what shall be done? For example, if we want to round off this number, then it means that the number 5, it is 5 which is equal to that range which we need. So 5 is inclusive. So if that's the case, then we shall have 3, but this is 6. So this one is 5, we can see, and it is within the range. So meaning this number will round off, but this one will add with 1 to become 7, and the others will remain 0 because we cut them off. So meaning we shall just have our numbers 370. What do I mean? If you want to round off any given number, we check the number adjacent to it on the right hand side. If the number is within the range of 5 up to 9, if the number is 5 or range of 5 to 9, we round the number to the nearest tenth. So meaning the previous number which we need to round off will add with 1 to become a new number with the addition of 1. But if the number ranges from 0 to 4, then that number we ignore it. We just cut it off, or we ignore it and replace the number with 0, but the adjacent number which we needed to round off remains the same. For instance, if this our number here was 4, for instance, if we had 364 point that number, if we wanted to round off 6 to the nearest tens, then we shall check on this 4. But we see 4 is not equal to 5, or is not within the range of 5 to 9. It is within the range of 0 to 4. So meaning if it is within the range of 0 to 4, we just ignore this number and replace that number with 0, and our number remains 360.00, but we can cut them off because the other numbers are replaced with zeros. So in rounding off, we do check to the adjacent number to the right, And then if that number is equal to 5, or the number is within the range of 5 to 9, we add 1 to the number we are rounding off, and the others we replace them with zeros. And if it is below 4, or 4 itself, that means from 0 to 4, then that number we just replace it with 0, and the number we need to round off remains the same. So let's see this example. For example, we have 395.184. You are being asked to round off to the nearest hundreds. So if we have to round off the nearest hundred, we find that the digit of hundreds is here, is digit 3. So if we needed to round off the nearest hundreds, then we shall look at the number which is in the 10th digit. And if we look, it is 9. It is within the range of 5 to 9. So meaning it exceeds that 5, and means this number will add with 1 to become 4, and the others we shall replace them with zeros. So meaning if we do that way, we are only remain with so this one we are going to remain with the 400. So meaning if we round off this number to the nearest hundreds, we shall have 400. And if we have been asked to round off to 4 significant figures, if it is to 4 significant figures, what do they mean? They mean we round off to the numbers which are visible to 4 significant figures, and those includes 1, 2, 3, 4, 5, 6. So our number has 6 significant figures. So if it is to 4 significant figures, we shall count starting from the left hand side. Meaning this will be 1, 2, 3, 4. Then we shall check on the 5th significant figure number. So that one is 8. And if you look at 8, it's within the range of 5 to 9. So meaning we can now replace it with the 0, but the adjacent number which we are now to round off to that number, it will have an additional of 1, and it will become 395.2, but the others will replace with the 0. So that is our number, or we can still write it 395.2. This is the number to 4 significant figure rounded off to that number. So we can still round off maybe to the nearest whole number, and if it is to the nearest whole number, we are rounding off to the nearest whole number, meaning without the decimal place. So if it is without the decimal place, that is whole number. To the nearest whole number, we shall round off this 395.184, but this one is less than 5. It's within the range of 0 to 4. So meaning we cannot add here any number. So it will remain 395 point. Now that one will remain with 0. We replace it with 0 because it is within the range of 0 to 4. So the others replace with the 0, but the number here, which is to the nearest whole number, will remain that one. So that's what we find. But this one means these zeros after the decimal place has no significant information. So we can replace them, we can wrap them and remain with our answers 395. So we can round off the number to 2 decimal places as we have here. So to 2 decimal places, we can round off 395.184 to 2 decimal places, and you will find 2 decimal places, we have 1, 2 after the decimal places. So we need to round this number. The number which is to be rounded off is number 8. But on looking on adjacent number which is on the right, we find it is 4. It is from the range of 0 to 4. And if we do that, you will find that it has no, it does not exceed, or it will be within the range of 5 to 9. So we replace that number with 0, and this one we shall remain the same, So we shall have our number as 395.18, and that one is 0, but there is no need of writing it. So we shall have that one to 2 decimal places. And that is how we do rounding off. Let's see how we may truncate given numbers to given conditions. For example, having 365.427, and you have been told to truncate this number to 4 significant figures. So truncation only here means that you find the numbers which you have been told to truncate, and then after seeing that kind of number, you cut off at that point. The rest are ignored after cutting off. For example, if we have been asked to truncate this number, or you truncate this number to 4 significant figures, you count the number of significant figures you want. For example, here is 4. So counting off, you will find we shall have 365.4. So if it is to truncate, you just cut off. So the rest of the numbers are ignored. Even if whether this one was to be 7, you don't round off, you just cut off. So meaning that if we cut off to 4 significant figures, we are going to have 365.4, and that is what we shall have. And if it is to truncate to 5 significant figures, to 5, this is to 4 significant figures. But to 5, you will have 365.42. You don't round off 7 so as this one becomes 3. No. You just cut it off and then you put it the way they have asked. In case you have been asked to truncate the number to 1 decimal place, you just come and check the number to 1 decimal place. It is only this number. So we are going to truncate it up to that point, and you will give your answer as 365.4, which is similar to 4 significant figure. That is how we do truncation to numbers we have been given with the given condition. If it is truncation to 4 significant figure or to any kind of significant figure, you just cut at that point. But if the number is even less than 4 or 0 to 4, you don't round off. If it is from 5 to 9, you don't even round off. You just cut off and the rest of the numbers are ignored. Let's check how we may find estimations under this approximation. And the estimation here, we just find that estimation involves rounding off given numbers in order to have an approximate answer or to calculate given conditions or numerical figures faster. So if we are being given, for example, estimate the answer of, for example, you have 152 here for my case, multiplied by 269 over 32. So if I am to estimate this one, we have said you just round off a given number so as you may have faster calculation. For faster calculation, so here I may round off. The first one I will round off is 152. If I round off to the nearest possible number, I will find this one. If I round off, I'm going to round off this 5. So if I round off this 5, I will check at number 2. This the one in 1. So that one is less than 5, so I will have 150. Then I multiply by 269. I will check at this 9 because I'm rounding off this 6. So I will find this one is greater than 5. So it will add 1 to this one. So I'm going to have 270. And then on this 32 is the same as the ones here are the same. So meaning the number will remain as 30. So if I do that way on calculation, I've taught you how to calculate using a calculator. So I will find out that that is 150 multiplied by 270 divided by 30. I'm going to get my answer as 1350. But this was just an estimate of that answer. But if you do the real answer of this one, you will find that on doing the reality of this one, that is 152 multiplied by 269, over 32, you will find your answer to be 1277.75, on which if you round off to two significant figure, you will find out it is 1300. If you round off to two significant figure, you are getting is 1300. To two significant figure, you will find is 1300. Here, that's what I find as to two significant figure, I'm getting 1300. So I can say the real answer is this, but if we round off is 1300, but this one is nearer to what we estimated. So we find that if you estimate an answer, it doesn't give you the actual answer you require. It only gives you an answer which is approximate to the exact answer you want. So sometimes some numericals require estimations, and if you estimate, that is what we said, you just round off the given number to the nearest possible, then you calculate as it is for faster calculation only. Let's see how we might find accuracy and errors. And in this section, we know that if we encounter different kind of measurements, for example, mass of a baby, you may find even the length of the rope. Like if you have a room, you will also determine the volume of that room or area, or even the width, length of it. You will do some measurement in order to encounter that one. And you will find that whatever you will just be finding is an approximation of what is the real length of that measurement. So the accurate measurement is what we are referring to exact measurement. That is the accuracy of it. And then the errors now comes in if we take the difference between the exact length or the exact measurement of that given quantity you are measuring and the approximation of what we have. That is what we refer to error. If the error is too big, then the accuracy of that kind of measurement you used is very low, so we cannot rely on it. But if the error is too small, then it means the accuracy is very high, and that we can depend on that kind of instrument you are using for measurement. For instance, let's see how accuracy of instruments are. Under accuracy of instrument, we shall find that under accuracy of instrument we do measure using rulers, for example, in our daily life in schools and other kind of measurement, either tape measure or something like that. We do measure in meters and something on. So we may find that if we use a ruler, you will find we are giving a length of, for example, 3.6 centimeters. We may give a length of 3.6 centimeters. Under this one, we only discover that this is not the exact measurement. This does only give us information that whatever we have measured, it has a length which is approximately more closer to 3.6 than being further away from the other measurement. So meaning that it is more closer to 3.6. And if we use another kind of measurement like a vernier caliper and also a micrometer screw gauge, you will find those one gives in thousands of measurement. For example, you will find you may have a given kind of object having measured like 0. Not 0 but 2 point, for example, 125 centimeter. This one, it has been measured using either a micrometer screw gauge or a vernier caliper. So you will find that if you find the error in the measurement of this one and that of the ruler, you will find this is for ruler and this one is for either vernier caliper or for micrometer screw gauge. So if you do that one, you will find that the error that will be found if someone uses a vernier caliper or micrometer screw gauge in measurement, you will find that the error here is too minimal compared to the error found using 3.6, that is for ruler. So meaning that these measurements are more accurate compared to that of ruler. But at the same time, you may find we do measure some of the length, or we do measure masses or something like that using electronic devices. For example, a weighing balance, which is electronic. So you will find if you use an electronic device, for example, in calculation of mathematics, we use calculators. And if we need to measure, for example, the mass of a given, most of us will use meat, for example. So the mass of a given kilogram of meat, you will find if we use an electronic device, you will find that an electronic weighing balance will measure that one more accurately than using the manual one. So we find using a vernier calipers or micrometer screw gauge, or those instruments which give figures which are much more smaller in errors, they are more accurate than the others. Like for example here, the vernier calipers and micrometer screw gauge is much more accurate than the ruler. And we can witness that if you use a ruler here for this case, you will find this value which we have found here is just an approximate of the exact value. So meaning it's just close to 3.6 centimeter, meaning that this measurement here lies between 3.55 centimeter and 3.65 centimeter. But it's not 3.5, it's not 3.6, it's not close to 3.5. 3.6 is not close to 3.5 centimeter and 3.7 centimeter. It's not close to them, but it lies within 3.55 and 3.65 centimeter. That is why we took the average of them, and we say that if you hear that is the measurement, then that means it lies within that point. And if you have 2.125 centimeters for an object being measured by a vernier caliper, it just means that this object is within the range of 2.1255. Actually, that's the highest of it. 2.15125 is within the range of 2.1245 and 2.125. That's the range where that one is located, but it is not it's not close to 2.125, it's not close to 2.126, and not close to 2.124. It's not close to them, but it's close to 2.1245 and 2.1255. So that is why we take an approximate as the middle one, and we do say this one measures 3.6 centimeter and this one measures 2.125 centimeters. Let's see how we may find absolute error using the measurements we have been given, for example. So here we have absolute error, and from this we can see, for instance, we had a certain given object measured by a ruler, and we got its measurement as 3.6 centimeters. And from this we did say that this object is measured to the nearest millimeter. And from this we can say it is close to 3.65 is close, 3.6 is close to 3.55 centimeter and 3.65 centimeter. And from this we can say this is the lower limit of this measurement, and this is the upper limit of that measurement, in that measurement lies within 3.55 centimeter 3.6 centimeter, which is less than 3.65 centimeter. So the measurement lies within that one, meaning the lower limit of that measurement is 3.55 centimeter and the upper limit is 3.65 centimeter. So if we needed to find the absolute error in this whole part, we now take 3.6 centimeter, which is our now measurement, we subtract the lower limit, and we shall find, if we do that one, now we shall find absolute error as, we are going to get it as, you take the real measurement which we have find, or our approximate, which is 3.6, or the working measurement, that is 3.6 centimeter, we subtract the lower limit of that measurement, which is 3.55 centimeters, so we are going to get 0.05 centimeter. And at the same time, if we do take, for instance, 3.65 centimeter, which is the upper limit, and we subtract 3.6 centimeter, which we take this as our reading, then we shall have positive. And here, actually, I did it in the different way. It should be it should be 3.55 centimeter. Subtract 3.6. That is our limit here. So you will get negative 0.05 centimeter. And if you do this way, you are going to get a positive answer. So this one is going to give you positive 0.05 centimeter. So in doing that, we can say that the absolute error here, which we are finding here, it is 0.05. Here is negative, that is positive, just to give us the sign. But we know if we need that answer, we just find the absolute value of that answer, and we find our absolute error here is 0.05 centimeter. That is our absolute error. But we know one thing. From here, we know that this measurement is measured to the nearest millimeter. If it is measured to the nearest millimeter, then it means the least unit of measurement used here is 0. Actually, the least unit of measurement is equivalent to 0.1. That is our least unit of measurement here. But if we need to find the absolute value, absolute error, not value, the absolute error that may occur here, we shall now take, because that one is the least unit of measurement, we just take a half of the least unit of measurement. So we shall take a half of it, and you find, if you take a half of 0.1, you are going to get 0.05 centimeter. And you identify that this one is the same as taking the lower limit of any given unit of measurement, subtract the given or the required, which is 3.6 for this case, and if you do that, you are going to get the absolute value of that given instrument. Generally, the absolute value or the absolute error, so the absolute error of any given or stated measurement is the same as taking half of the least unit of that measurement. If you take a half, as we have done that one, you will find the absolute error of that given measurement. Let's see how we may find relative error of given measurement. In relative error, what we are going just to consider here is only the absolute error. In this case of measuring masses, for example, AG, we may have different kind of masses. We may take, for example, let's take a mass of we may even take a mass of a hen. Let's say it's 2 kg. And that of a bull, let's it be like let's take it as 225, not a bull, but let's take that of a goat. Will it give us weight? Let's take the mass of a cock. Actually, let's say it be 2 kg. And let's take that of maybe a bull to be 200 kg. And we've been told that there is an occurrence of error in any of them, that is an error which occurred, absolute error of 0.5 kg in the measurement of the masses. In any of them, every of them, there is a deduction of 0.5 kg of measurement. That is the absolute error. It may be either an increment or a deduction depending on the amount of measurement. So, from this section we can say if this one is the absolute error, then we can find the relative error. And if you need to find the relative error of any given kind of measurement is located by taking the absolute error over the actual amount or actual, let's say actual measurement stroke amount or value as it may be. So if you do that way, you will have find the relative error of any given measurement or any given condition. For instance, here we have been told the cock here, it has 2 kg and the absolute value or the absolute error that occurred is 0.5. So we can find the relative error with respect to the cock. Let's do it here. Now cock, so relative error of the cock will be equal to the absolute value in each of them is 0.5 kg over now the mass or the weight of the cock is 2 kg, so it is over 2 kg, and we find it's going to give us you're going to get 0.25, and this is the relative error. It has no unit, and that for the bull, which we require there, it is 0.5 over 200, and we shall find this one is going to give us, actually it's much more minimum. It has no unit too. So we can state that the relative error found by using or calculating that of a cock is greater compared to that of the bull, because this is too minimal, 0.0025, and this one is 0.25. So if it is a loss, it may be much more greater when using a larger scale. That is when the relative error is present in a way that the mass is too small. Then we find here it is much more greater and has much more great impact on the measurement here. And here it is too small, meaning the accuracy is too high and it is having much more small impact on it. So we have find the relative error of any given kind of measurement. We do take the absolute error found of that measurement, of which we say absolute error is equal to the half of the least unit of measurement. So if you take the absolute error over the actual value or measurement or amount, then you will have find the relative error. And relative error has no unit. Then let's see how we may find the percentage error. So in percentage error, for the first, for the cock for instance, we found the relative error of that cock, relative error, we found it to be 0.25, and for the bull, we found it to be 0.0025. Now we can find the percentage error. And the percentage error, we do say that we shall take the relative error multiplied by 100%. What you have as the relative error here, you multiply it by 100% and you shall have find the percentage error of that given measurement. Or you can use it if you don't need to find this one. You can still take absolute error over actual value, then you multiply by 100%. This is the formula for finding relative error, and then you multiply 100%. It's still the same. For instance, the percentage error of the cork here, for example, we shall find it as percentage error for the cork. You will find it will be 0.25, you multiply by 100%. So that one is going to give you 25%. And if you do the other way around for the bull, you will get that of the bull will be 0.0025 multiplied by 100%, and you are going to get that it's going to give you 0.25%. So having that one, we can relate the two percentage in error, and you will find that of the cocoa is having higher percentage than this of the bull. So the percentage, or those things that have high percentage error, like that one, they are less reliable compared to those of small percentage in error. So we can say to find the percentage error, we just take the relative error, you multiply by 100%. But you remember how to find relative error, you just take absolute error over the actual value, and that is how you find relative error. Let's now see another example whereby we have been told the thickness of a coin is stated as 0.20 centimeter. Now, a question asks that calculate the percentage error. And remember here we said that to find the percentage error, for this case, we shall take the absolute error, actually it's the relative, is the same as taking the relative error multiply 100%. I just write relative error by 100%, or you take the absolute error over this absolute error over the actual value, or actual value, actually is actual value multiplied by 100%. But remember here, this one here, which we call absolute error over actual value, we did say that this one will give you relative error, and relative error has no units. So we are going to calculate, in case when we are given the thickness of a coin as 0.2 centimeter, then we are going to calculate the absolute error first. And remember, to find the absolute error, we did say that this one is a half of the least unit of measurement. For this case, we have been given that measurement to 2 decimal places of accuracy. So meaning that the least unit of measurement shall be stated as 0.01 because it is to 2 decimal places. So this one shall be in centimeters. But if we need the absolute error, then it shall be a half multiplied by 0.01, which is the least unit of measurement. And if we do that, we are going to have this one as a half multiplied by this one, we are going to get is 0.005 centimeters. So meaning that in case of finding the percentage error, then it shall be absolute error, which is 0.005 centimeters, divided by the actual value, which is 0.20 centimeters, then we shall multiply by 100%. In that case, if we calculate, we are going to find this one is going to give us a value of 0.025 multiplied by 100, and this one you shall have it as 2.5%. That's the value which you find when the thickness is stated to 2 correct decimal places of accuracy. Then let's see, in case where you are being told what would be the percentage error if its thickness is stated as 0.2 centimeters. In case when it is stated as 0.2 centimeters the thickness of that coin, then this is to 1 decimal place of accuracy, and meaning that the least unit of measurement here, now it will be 0.1 centimeter. And if that is the case, we shall have our absolute value as our absolute error as 0.5 of the least unit of measurement, and that is of 0.1 centimeter. And this one is amounting to 0.05 centimeters. In case of calculation of the percentage error, remember percentage error here, we did say that you can find it by taking the relative error multiplied by 100%, or you just take the absolute error over the actual value multiplied by 100%. But don't forget that the absolute error over the actual value is equal to the relative error. And in that case, we are going to have that here the absolute error we are having 0.05 centimeters divided by the actual value, which is now 0.2. And this one here, we are going to multiply it by 100%. So centimeters will cancel, and you will find that here we are going to have 0.5 over 2, and this one you will have it as 25%. If you calculate that one, you're going to get 25%. But remember, if the coin here, the thickness of that coin is stated as 0.20 centimeters to 2 decimals of accuracy, then here we had a percentage error as 2.5%. But in case it's stated as 0.2 centimeters, of which it is to 1 decimal place of accuracy, then we are going to have there as 25%. So meaning that when you give more numbers of decimals of accuracy, then it is much more reliable than giving few numbers or small of the numbers of accuracy. So you can see the percentage error in this case of 0.2 is much more larger than that of when it is stated in more numbers of decimals. So we can see this is 25 and this is 2.5. Now let's see how we round off and truncate some errors. And here we shall find that if we have some kind of given data and we do truncate or measurement, you will find out that the resulting is quite different from the original. For instance, if we have, for example, let's start with the round off errors. So at this point here, you will find that in case we have 1.66666, or let me just write, so meaning this is the same 1.6 recurring. So if we round off this one to 1 decimal place, you will find that you will have 1.7. But if you take this 1.7, you subtract the original, which was, now this one will be 1.6666, so that is 2 over 3, and this is 1.7. Because this is 1.66, if you round off to 1 decimal point, you will find it's 1.7. So that is 7 over 10. So that means it's the same as writing 7 over 10 minus 2 over 3. And you are going to get your answers as 1 over 30. So we have found that if you find the difference between the rounded off value with the real value, which is the real value was 1.6666, which is the same as 1 and 2 over 3, 2/3 actually. So if you find the difference between the rounded off value, which was 1.7, and that one, you do get 1 over 30. This is what we refer to round off error. So that is what we are referring to, round off error. Now let's see truncation error or truncated error. Here, if we have the same here, for instance, and we do truncate, for example, it was 1.66666 recurring, which is 1 and 2/3, or equal to, actually it's 1 and 2/3 because it's 1.6 recurring. You will find, if we truncate to two significant figures or one decimal place, you will find you will have 1 and 1.7. And after doing that, actually it's 1.6. 1.6. Truncating, we don't round off. We just cut off the remaining and ignore them. So we cut to one decimal point at that point and we remain with 1.6. And this one, if we do that one, we are going to get is 1 over 6, 6 over 10. And if we do subtract from the original, which is 1, 2 over 3, we shall see that it is 1, 2 over 3 minus 1, 6 over 10. And you are going to get that we are going to have a difference there. We are going to have 1 over 15. So this answer which we have found here, which has been located by truncating that decimal places to one decimal place here, the answer is 1 over 15. This is what we are referring to truncation error or truncated error. The other one was round off error, and that is truncation error or truncated error. This one was found after rounding off to nearest one decimal place, but this one we just cut, that is truncation. So we have seen how we do that. So in our next session, we shall see how we can propagate errors. Let's check now propagation of errors, and we shall start with the addition. Under propagation of errors, we are just dealing with the multiplication, addition, subtraction, and division of errors. And we know if we use approximated values, then it means that the resultant values will also be approximations. So here, we are going to see some of the examples and how we may propagate them and how the errors may be propagated throughout the examples. For instance, we may be told what is the error in the sum of 2.5 m meters and 3.6 meters if each represent a measurement. We have been given 2.5 meters and 6.5 meters. That is 6.3 actually. 6.3 meters. So we have been told to find what is the sum of 2.5 meters and 6.3 meters if each of them represent a measurement. What we shall do here, we find the working and the minimum or the least or the lower limit of each of the measurement and also the upper limit of each of the measurement. For instance, having 2.5 meters for this case, we can find its upper limit, and its upper limit we can find it by, first, let's find in each case the absolute value. If we find the absolute value, we are going to get the absolute value will be a half multiplied by the least unit of measurement here, and the least unit of measurement is 0.1 meter. So we are going to get 0.05 meters. So the least the upper limit will be with the addition of this one, so it will be 6.35 meters, and the lower limit will be actually 2.5 meters, 2.55 meters with the addition of that, and here will be 2. We subtract that 0.05 and we shall get 2.45 meters. So that is the limit within, or the boundary within 2.5 meters line. And for 6.3 actually meters, it will lie between 6.35 meters and 6.25 meters. That is the boundary within which it lies. So we need to find the maximum possible area, maximum possible sum, and also find the minimum possible sum and the working sum. So let's start with the working sum. Working sum is found by taking the actual values, we just add them. For instance, here we shall just take 2.5 meters, we add it to 6.3 meters, and we get our answer is equal to 8.8 meters. And for the maximum possible sum, we shall find which one, if we do sum, we shall get the greatest possible sum. So we find it will be within the upper limits. So we shall take 6.35 meters plus 2.55 meters, and this one will give you something. We are going to get is 8.9 meters. So that is the maximum possible sum. Let's check the minimum possible sum. So the minimum possible sum, we are going to find it is equal to the lower limits, which is 2.45 meters plus 6.25 meters, and we shall get, we are going to get this one at 8.7 meters. So on viewing the two, we can find out that this is 8.8 meters, 8.9 meters, and that one is 8.7 meters. So if we need now to find the absolute error in the sum, we shall now take the working either of them. We shall take maximum error minus mean working error. Actually, it's maximum error minus working error. We will have find absolute error. Actually, we were dealing with the sum, so it's not error. So maximum sum, and this is the working sum. And if we do that, we shall get absolute error. And that is, here we have 8.9 meters as the maximum possible sum. And then we subtract the working, which was 8.8 meters. And we shall find here, we are going to have 0.1 meter. So we have found 8.9 meter minus 8.8 meter, we are going to get 0.1 meter. Or you can still find absolute value by taking working sum, then you subtract the minimum sum. And this one is going to give you 8.8 meters minus 8.7 meters. You will get this one as 0.1 meters. So this 0.1 meters here, it is what I'm referring to absolute value of the sum. You can still find that one in two ways. That is the first way. the second way, you can take each individual error. For example, if it is in measurement of 2.5 meters, you will find that the absolute value here will be equal to a half multiplied by the least unit of measurement, which is 0.1 meter, and you get this one is 0.05 meter. And the other way, which is 6.5 meter, you will find it is a half multiplied by 0.1 meter, and this one is going to give you 0.05 meter. So, meaning that if you need to find the sum in absolute error, you will now take the 2, which now will be absolute error. You will find it as the sum of the 2, which is 0.05 plus 0.05, and this one is going to give us 0.1 meter, which is found in either of the way. So we have seen this is just a simpler way of finding the error, and we can use another way. Now we do have to deal with the subtraction, and we shall consider one of the example whereby we have been told what is the difference between the measurement of 0.5 grams and 10 grams. So the first thing we shall actually is 10.0 grams and 0.5 grams. So we needed to find the upper limits of these grams, that is upper limit we needed to find that of 10 and that of 5. So what we shall do, the first thing here, we need to find the absolute value, so that in case we need to find the upper, we should add to that, and if we need to find the lower limit, we need to subtract from this. So what we shall do, we need to find the lower limit, lower unit of measurement, and we shall find here is, in both cases, is 0.1 grams. So absolute value is a half of that, so it will be a half of 0.1 grams, and we shall find is 0.05 grams. So if we find the upper limit of that, we shall find this one is going to become 10.05 grams, and lower limit is going to become, actually it's 9.95 grams, and here will be 0.55 grams, and here will be 0.45 grams. So if we need to find the difference between the two values, then we need to find the working difference, and we shall find it as 10.0 minus 0.5 grams, and we shall find this one as 9.5 grams. So if we need to find the maximum possible difference, we shall now take the one which appears to be more of it. So the maximum possible difference, it will be this maximum upper limit minus the lowest lower limit, which is now 10.05 grams minus the lowest lower limit, which is 0.45 grams. And we shall find here, our answer will give us 9.6 grams. Then we need now to find the minimum possible difference, and we shall take 9.95 grams minus now the maximum of it, the maximum lower limit. Actually for this part it will be 0.55 grams. So now we did the other way, and we found the maximum difference was the maximum minus the lowest minimum lower limit. So we find this. So now we need to find the maximum lower limit minus the lowest upper limit, which we shall have like 0.55 grams. So doing that, we are going to get this one as, actually it's 9.4. 9.4 grams. To verify this, if you take this minus this one, you are going to get 9.5. So meaning the minimum difference here is 9.4, not 9.5 grams. And if you do the other way, here we got 9.6, but if you do this one, it's going to give you 9.5 actually. And that is not the maximum. So the maximum is 9.6 grams. So if we need to find the absolute error, now it will remain the same formula, whereby it will be the maximum difference minus working difference, and you shall find it is the same as 9.6 minus the working difference was 9.5, and you get this one as 0.1. You are getting that one as 0.1 gram. And at the same time, you can find it by taking absolute value as minimum difference minus working difference, and you will find it is minimum difference here. Actually, you will take it the other way. It's working difference minus minimum difference, or find the absoluteness of the value, and you will find, let's start with the other way around. Working difference minus minimum difference, and you will find this one is 9.5 grams minus 9.4 grams, and you're going to get this one as 0.1 grams. So we have found the absolute value in either case is the same, so is 0.1 grams. So we shall look in our next session how to find the absolute value using the propagation of errors, and how to find absolute values in multiplication and division. Now we are having multiplication here, and we have been told a rectangular pond measures 5.3 meters and 2.5 meters. So find the absolute error in the area of the pond, and also the relative error in the area of the pond. So what we are going to do here is only one thing. We need first to find the length in which the limits in which the length and width lies. For instance, the length of that rectangle is 5.3 meters, and we can find out in which limit that does it lie. And then we know, we have been told that its width is 2.5 meters, so we need to find the limits in which it lies. So we are going to do it by finding the least unit of measurement. So least unit of measurement, we are going to find in both cases is 0.1 meters, because that is the last unit there. So we need to find absolute value, and absolute value in this case we shall find it as a half of the unit of measurement, and we are going to get 0.1, and that is 0.05 meters. So meaning this one will lie within the, actually it's 5.35 meters, and here it will be 5.25 meters, and here it is 2.45 meters, here is 2.55 meters. So to find the greatest area, we need to check first. Let's first work out the working area. And we know the area of a rectangle is equal to length multiplied by width. So the working area will be 5.3 multiplied by 2.5, which we have here, 5.3 by 2.5, and we know this is meter squared, so we are going to get something like 13.25 square meter. So after getting that, we need to find the maximum possible area, and we still know it's length times width. So that one we do find it in a way that, so the maximum possible area, we are going to get it by only multiplying the upper limits, which is 5.35 multiplied by 2.55, that is meter squared. So this one is going to give us 13.6425 square meter. Now, after doing that, we need to find the minimum possible area. And that one we are going to get as 5.25 multiplied by 2.45. And we shall get this one as 12.8625 square meters. So after doing that, we now need to find the absolute error in the area. So if we do that, we shall take the working area. For this, we see that the product here is not the same. The products for the maximum and the minimum is not the same. Meaning, if we do the subtraction, we are not going to get the same things. In case, let's just see. We can take now absolute error, but before that, we shall take maximum area minus minimum area. Actually, let's start with the working area. And we are going to get is maximum area we got is 13.6425 square meter minus 13.25 square meter. So doing that, we are going to get 0.3925 square meter. So that is for the working maximum area minus working area. Now we are going to get the working area minus minimum area. So we shall find the error there that occurred. This was the error. And here we can also find the error. And we shall find the error here will give us, that was the minimum area, working area is 13.25 meters squared or square meter minus 12.8625 meters squared or square meter. So we are going to get we are going to get 0.3875 square meter. So if you check the two errors, you will find that they are not similar. So to find the absolute error, we need to add the two errors, and then we divide by 2. 3925 square meter, we add to 0.3875 square meter, then you divide by it by 2. For any given circumstance, if you have to do it, that's what you should do. You find the maximum area minus minimum or the working area, then you find that error. And also you do working area minus minimum area, you find the error, you add the two errors, you divide by 2. Or to minimize that kind of tediousness, you just take the maximum area minus the minimum area and then you divide it by 2. You will just be doing the same thing. So on this one is going to give us 0.78 divided by 2. Our absolute value actually is an absolute error is equal to 0.39. So we have find our absolute area is 0.39 square meter. So that is what we are having as our absolute error. But we were told also to calculate the error in the area of the pond. So error in the area of the pond. So finding the absolute error here, we are going to divide it by 2 and you will find this one is going to give you 0.39 square meter. But we have been asked to find the relative error also of the pond. So if we need to find the relative error, we did say that relative error of any given kind of measurement, we say it is equal to absolute error divided by the actual value. For this case will be the working area. Then this one will be giving us that relative area. If it was a percentage, we could multiply by 100%. But for this instant, we are going to read that point. So our absolute area is 0.39 square meter. But remember, our working area, we found it as 13.25 square meters. So if we do that way, we are going to find the relative error. And we can say it is equivalent to 0.0294 significant figure. So that is where we find relative error, and we have also find the absolute error. The first thing we have to identify is only to find the working area, maximum area, and minimum possible area, and then from there we do take the shortcut and take maximum possible area minus the minimum possible area. And then the value we get, we divide it by 2 so as to get the absolute error. After getting the absolute error, to find the relative error, we do just take that absolute error divided by the working area, and that is what we do find there. Let's see how we may find quotients of given kind of areas or measurement. For example, given 8.6 centimeter divided by 3.4 centimeter, find the absolute error in the quotient. So if you need to find the absolute error in the quotient, then what you should do here is only you find the limit within which the given measurement lies. For instance, for our case here, we are going to find the limits, and we shall find, the first thing to find is to find the lower unit of measurement, or the least unit of measurement, and we shall find in both cases is 0.1 centimeter. After finding that, you find the absolute value here, because that is what we shall be adding or subtracting to find the lower and the upper limits of those measurements. For example, we shall multiply by 0.1 centimeter, and we shall find the absolute value here is going to be 0.05 centimeter. So meaning that our values here lie within 8.6 centimeter, lie within the limit of 8.65 centimeter and the limit of 8.55 centimeter. And the other one, which is 3.4 centimeter, lies within 3.45 centimeter and also within an interval of a minimum of 3.35 centimeter. From there now, we can find the greatest quotient, working quotient, and also the minimum possible quotient. And from here, let's start with the working quotient. Working quotient is obtained by taking the values which we were being given, that is 8.6 divided by 3.4. This one is going to give us, you'll find this one divides, and you will get so we are going to get it as the quotient of that one is going to be 2.5294 to 5 significant figures. And then we shall find the maximum possible quotient, and maximum possible quotient is equal to, now what we do here for division and subtraction, what we just do here, we take the maximum greatest upper limit, which is 8.6 for this instant, 8.65 centimeter. Then we shall divide with the lowest lower limit. And for this case, the lowest lower limit is not this one, it will be 3.35. So you divide by 3.35 centimeter. After doing that, whatever you are going to get here will be the maximum possible quotient. And you get this one to be 2.52 5, 8 to 1 to 5 significant figure. Then we need to find the minimum possible quotient. So to find the minimum possible quotient here, we shall take 8.55 centimeter. Now we divide by the one which we have now remaining is 3.45 centimeter. And if we divide it here, we are going to get another kind of sum. This is going to give us 2.4783 to 5 significant figures. And remember that the LCM and the units actually are disappearing because we are dividing, so the units are going out. And we can really, from there, we can calculate the errors obtained here. For example, we can start with the maximum minus working quotient, and we shall find for that instant is going to be maximum quotient. We have 2.5821, and the working quotient here we had 2.5294. So we shall subtract 2.5924 here, and we shall get the error here that occurred. We are going to get it as 0.0527. This is the error that occurred between the working and maximum. And now let's find the error that occurred between the minimum and the working. So we shall find the error is working minus minimum quotient. So we are going to get it as the working quotient we got is at 2.5294 minus now the minimum one we have 2.4783, and if we do that we are going to have 0.0511, and this is the quotient obtained between the working and the minimum, and we can say the two are not equivalent as it was in the sum and difference. So what we do here, we shall sum the two errors, the error obtained from working and minimum quotient, and that error obtained from maximum and working quotient, and then we sum them together and we divide by 2 to get the absolute error. Or we can just go by shortcut by taking the maximum error minus the minimum quotient. That is the maximum quotient minus the minimum quotient, and then we divide by 2, and we shall get the same answer for this case. Now let's do it. We shall find out that if you take 0.0511 plus 0.0527, then divide by 2, whatever you are getting here is what we call absolute error. And that one is found as this is equivalent to 0.1038 divided by 2, which is giving us 0.0519. So this is our absolute error. And if you are being asked to find the relative error in the quotient, then whatever you are required to do here, the absolute value in the quotient, the relative error In the quotient, it will be absolute error over the working quotient. And we shall find out that the absolute error we found out as 0.0519 divided by now the working quotient. Remember the working quotient we found is 2.5294 from our previous working method. So if we do that, we are going to get the relative error. So we are getting this one as 0.0205 to 3 significant figures, or to 4 decimal places. With that, we have come to the end of the topic approximation and errors.